Good morning. Hi everyone, welcome to the second lecture for COMP1531. I hope you've had a good day, I hope you had a good couple of days. And we're going to get stuck into some more kind of, I guess, practical skills today, in particular with Python. Most of what we're going to be doing today is around Python. So that should be fun, because students seem to always love programming as like a pretty common thread. How many people we have here at this 9 a.m. class? We have 120. We have 1 out of 3 people compared to yesterday. That's excellent. People don't love morning lectures, as you could imagine. Though at least it's better than when we went to campus, and everyone was there like super early all the time. That kind of sucked. So I'll get stuck into it pretty quickly today. The two main topics that we're going to be running through today are both the introduction to Python, which is really just about, how do we work with the programming language, and then also an introduction to testing in the context of software engineering. And we think about testing a little bit more philosophically at the moment, though we do a lot of examples with Python. So this is one of two big testing lectures. We do more on testing later in the course, where we learn a bit more about testing philosophies and whatnot. I can't remember where it's been slated into at the moment, but it's definitely... can't remember where it is. It's somewhere. We do talk about testing more later on. So first, let's jump into Python. 1.3 Introduction to Python. Now, in terms of this particular lecture, again, I'm just going to open up VLab, which means I'm just going to use Tiger VNC to connect, and we're going to do stuff on VLab. I think a friendly reminder for students as well, that if you're ever in a pinch and you don't you don't have Tiger VNC, or you're having problems with Tiger VNC or something similar to that, remember that you can always just Google Web VLab, because what Web VLab will do, if you kind of click on the link that says CSE in it, then what you'll see is that this Web VLab link will actually take you to this weird web-based version of VLab where you can click on a screen size and actually access the CSE computers via your web browser. This is not a great way to interact with it. Okay, so accessing VLab through Tiger VNC is pretty good. It's pretty stable. It's pretty easy, though. This is great if you're in a pinch. So for instance, if you're on a friend's computer, or if something's wrong with your computer, or you're having issues with Tiger VNC, etc., 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 this is totally fine. Now, if we go back to VLab with Tiger VNC, we're going to try and do a couple of basic Python questions, right? And I'm just getting this set up. So when you are when you're working with Python on the CSE machines, you can do it all through VLab, and you can do it all locally. It's all very straightforward to kind of do on any kind of system. So if some people would like to, how would you put it? Just use your local machine for Python, and that's absolutely fine. That's totally up to you. Lots of people kind of want to do that, and we get that, so that's fine. Just reading some questions in the chat. Okay, so introduction to Python, and I think I'll point out to people too. So occasionally, with these streams, naturally, occasionally we're going to have the odd technical issue and stuff. I want to remind people that these lectures are recorded at 1080p, 60 frames a second, kind of high quality. The streaming is naturally has a compression algorithm on it with a relatively aggressive bitrate compression at the moment. So if you aren't super keen to watch lectures, or there's internet problems or something, you can just watch the recordings. They go up pretty quickly. So let's get stuck into Python. So something we're trying to do is, at the start of every single lecture, we want to talk a little bit about what's in this lecture and kind of why we're doing this lecture. So in this case, Why are we talking about this for the next hour? And the answer is because Python is a valuable tool to learn in the context of just programming in general, and it's necessary for the project. Python is not necessary for software engineering. You can solve problems without Python in the context of software engineering, but it's a very good language to learn. The reason we teach it in this course is because if we don't teach it here, other courses that rely on it, it doesn't get taught anywhere. Basically, 1531 was the least difficult place to teach Python, so that's why it's here. And what we're going to be talking about in this lecture is learning a second language. What does that look like? Python versus C, the core Python language features, and Python versions as well, just at the end. Sorry, I always do that. Which is pretty fine and easy. So, firstly, what the hell is Python? Well, there's the logo for Python. Python is a high-level scripting language with rich libraries. That means that it has a lot of stuff that means you don't have to reinvent the wheel. So if you think back to like your time programming in C, you'll remember things like, oh, I have to write a length of linked list function, or I have to define my own linked list structure. None of that, because you have rich libraries for that. So you don't have to build the building blocks as much as you might be used to. And Python has common applications in, how would you put it, building simple services, utility tools, and all forms of data science. So what Python isn't really used for is high-performance applications. You tend to see other more low-level languages for that. It's used a little bit, though it's not the most popular when it comes to web development. Where it is very popular is kind of like, you know, simple services, scripting languages, utility tools. Like a lot of CSE is kind of built in Python, if that makes sense. Like a lot of things that actually run and like make the things tick behind the back in the backside are written in Python, right? So that's pretty cool. Like it's a really useful utility language. It's like I write Python all the time. I don't really build that many projects in it, but I wrote a Python script to allocate groups for this course. I wrote a Python script to push information up for the project. Like, it's a really great language to have a problem that needs a solution quickly to write some OK code. And because of that, it's used extremely commonly in the field of data science. In fact, like, Python essentially has becomes, how would you put it? Python is like, generally, I would refer to it as like the universal go-to language if you just had to pick one programming language. There is not like, there are other languages that have things Python doesn't, but if you had to learn one language, Python's probably the best because it's just pretty good and pretty general. It's not perfect at everything, but it's pretty damn good for most situations. You can see at the bottom here, like right there, this is an example of some Python code. This is a times table function, right? It's a function that essentially takes in a number, like a number 10, and it produces a times table. Times, yeah, the thing where it's like, you know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. So if you ever remember doing those in high school. What you'll notice about this is that it's relatively simple. Like, it's really simple code. If you were to imagine doing this in C, for instance, you'd have to kind of malloc some kind of array of a certain size and then create it and then free it. And then your loops would be a bit more complicated and you'd have to do increments and all this kind of stuff. Whereas with Python here, you're just like, okay, this is really simple. I've got a loop. I want to add things to a big long list. And then I've got this huge long times table list. Now, why Python? We kind of chatted about this before. But just to reiterate the point, the reason it's definitely very useful is that it allows you to rapidly build applications due to its high-level nature. So if I, say, take you back to RoboCup, the robot soccer team at UNSW, most of those robots, in terms of how they saw, how they kind of figured out where they were and how they walked, was all written in C++, right? Because it's very quick. But their behavior level, where they would make decisions about what to do, was all written in Python. And it was slow, but the reason that was done is because Python was really quick to develop and actually get things done. So it was like a rapid way to develop, which was what you needed. And in most cases, speed is not the end of the world, and the ability to work easily is really important. Python has a really straightforward toolchain to set up. if all of you are on Windows or something, or some non-Linux machine, and I said to you, go and get a C++ build version environment together, it'd be a nightmare, whereas Python's a lot easier. Compared to other high-level languages like JavaScript, Perl, Shell, PHP, and all that, it's considered very structured, so it's considered like it's just a really like clean language to use. And as I said before, it's useful in data science. Like, it's super popular in data science. I still use Python for data science applications all the time. Now, in terms of learning a second language, which is kind of like, even though this is a lecture on Python, even broader than that, it's really a lecture on learning a second programming language. Like, you've learned C. Some of you know more than that, but for many of you, this is your second language that you're learning. And learning another programming language is actually a really comfortable exercise if you already know a programming language, in particular, if it's from the same programming paradigm. So a programming paradigm is a way to group a programming language, because you have two languages, say like C and C++, or Java and C, or Python and Java, and they're all quite different, but some of them have some commonalities, which you can group them together. There's a really long list of programming paradigms on the right-hand side here, and there's a lot of overlap between them. They're not mutually exclusive. You can kind of read about this in your spare time, though kind of some of the most obvious ones are, you have like what you call your imperative procedural programs, like I guess specifically you have your procedural programs where they run from top to bottom, which is like C. And then you have like object-based programs, which you do more in 2511, object-oriented programs. Then you have things like functional programming, which are things like Haskell, and there's a few courses in CSE on that kind of thing. So in terms of these programming paradigms, the reason I wanted to point this out is because originally this had a very vague statement, which was saying learning a second language is easy. But if we were to teach you Haskell or Java, learning a second language is not as bad as learning your first, but there's definitely some mountains to overcome. So what I wanted to have here is a little bit of a comparison between languages to give you a sense of things. So for instance, procedural is that run from top to bottom, which you're used to with C. So let's have a look at C. C is a procedural, not object-oriented programming language. So they're the two paradigms here that we're interested in. And then I've added a few more pieces of information to the right, which is like, does the language is it a strongly typed language? As in, C has ints and doubles and chars. It has types for all the data you deal with. Yes. Does it have pointers? Yes. Well, can you interact with pointer arithmetic? Yes. And is it a compiled language, which means like, do you have to have a separate step to compile it versus running it? And the answer is yes. Now, there's a whole bunch of other things in this table, but let's go straight down to Python. And what do you notice about Python? Well, Python is also a procedural language, so you have the ability to write code that runs from the top and just goes straight to the bottom. It's also a object-oriented language, and it can be both. This kind of leads to a little bit of clumsiness in its design. I think that is a little less kind of clean as, say, Java or C, where it's like you're just dealing with one programming paradigm. Clumsiness is the wrong word. It's more like gives you a lot of choice, and sometimes that can be useful, sometimes it can be painful. Python, by default, is not a typed language. Python does not deal with ints and doubles. It figures that out for you. So you don't have to actually specify these things. Python doesn't have any interaction with pointers, which is generally considered a good thing, except in high-performance applications, so that's a good thing. And Python is also not a compiled language, which we'll talk about in a sec too. That means that you don't have a separate compiling step like you do with C, where it's compile and run. Now, these are not the only differences between these languages, and Python is very different from C, but a lot of the differences are syntactic, right? Like Python has if statements, it has while loops, it has variables, it has strings, it has printing. These are all things that we're not going to sit down and go through from scratch. We're going to talk about them quite quickly because as programmers, we expect you to feel comfortable learning the syntax of new languages. Where things are hard is when there are big conceptual gaps between languages, and when they're from different programming paradigms, you kind of have to teach yourself logical flows again. So our main focus will be on high-level things, and we'll be kind of assuming that you can pick up the small things relatively quickly, and that'll be true for the rest of your career. Like, they're a language, like once you learn a language, that's half the battle. And if you stay within that kind of programming paradigm or something that is quite similar, it's very easy to pick up other languages, right? Like a good example is C Sharp, which is a language that is like Java, was very, very fast for me to make sense of in an evening, at least half of it, because it's so similar to other things you've seen. Now, in terms of this stuff, I just kind of talked about this. I jumped ahead on the slides. These are the differences between it. I've just said this out loud, a slide too early. These are, Python versus C. In terms of Python versus C, we're going to go through lots of Python examples, but just a contrast here at the start, you'll immediately see the high-level nature of Python already. So let's compare a really simple function. This function takes two numbers in, and it returns the number 1, the number 2, and the sum of those numbers. So if I gave you 2 and 3, it would give you a list in return of 2, 3, and 5, the sum of those numbers. You can see here for C, it's kind of what you'd expect, which is like, you got to create another int, you got to create an array, you have to populate that array, and then you return that array, and you have to free it sometime later. Whereas something like Python, you'll notice that what we have here is just a really simple function where we're just like, yeah, 3 is just the sum of 1 and 2, and I'm just going to create a list. So very, very high level. And again, we'll go through some of these examples in a bit more detail. In terms of the language, we mentioned before that Python's interpreted we mentioned before it's not compiled. Some languages are like Python in which they're called interpreted languages. Now, interpreted languages, what they do is they compile and run it in one swoop. So Python is kind of compiled, of course. But what it means is that when there is no GCC step, you just run it straight away, and as part of that running, it will compile it. That can be really useful. Sometimes that can have performance issues. Yeah. So, excellent. Let's get on to learning Python. As I said before, because you already know C, or it's a prereq for this course. When we go through this, we'll go through it relatively. We won't go through it for weeks and weeks and weeks. You can read more about the Python language here. I think another thing to point out about Python is that there's a good reason I think we don't teach Python first. And the reason is because the surface area of the language is massive. And this is true for most languages, as in there is so many ways you can solve problems in Python. Like in C, there's typically just like literally 5 or 6 building blocks, and you can learn them in a term, and that's it. If you were trying to like be a world expert at Python, you could do an entire undergraduate degree on it. I'm certain of that. So don't kind of go into this being like, oh, I'm going to learn Python and then I'll have learned it. Because it's one of those things where we do some stuff today and you're like, I know a quarter of it. And then from there, you're always just trying to build things on top of your, knowledge already. And in fact, the way we really recommend that you learn Python is simply learn enough to start writing code. And when you run into a problem, when you run into something you don't know how to do, just simply Google it. Simply look it up in the docs and then learn a little bit more. And that's just kind of natural. So I just point that out because there's always some students who feel very worried about this because, they spend a couple of weeks on it and they're like, oh, there are things I don't know. And they're Googling it and they're seeing different answers. It's just like, it's just what we're dealing with here. It's just a little bit different. You don't need to worry about knowing everything. Just worry about knowing enough to solve your problems at hand. And before you know it, you will know well enough. You'll have plenty of knowledge. Okay, so let's actually start running some Python. Now, to actually write Python and run Python is really quite straightforward. And again, we can do this on the CSE machines. And I might make this one big. So what I'm going to do is I'm going to open a terminal here. And I might make this a little bit bigger because of the internet being a bit silly. Make this like, size 16 maybe. Oop. Feel like I did a dumb and forgot to click a button. Sorry. Okay, so derp. Okay. There you go. So there's our terminal that we're going to run Python in. Even VLab's being slow for me this morning. Big part of why VLab's slow is because I'm streaming the lecture. So there's not a lot of bandwidth left to chat to VLab. Damn. Okay. So let me just go into, is it 1531? Nope. Okay. This is a great, okay. We're going to do something in a sec. So one of the first things I'm going to do here is I'm going to create a folder called, well, I've already got a folder called 1531, but let's make another folder called CS1531. And let's go inside that folder. Now, what I want to do here is make a file, and I'll call it myfile.py, right? The file extension just helps tell the operating system what you're dealing with. So gedit myfile.py, and when I open this, I get a little gedit window, and, you know, Aurora asked me the question, run Python locally. Yeah, so I'll tell you why, again, I don't run it locally. The reason I don't run it locally is because there's a large proportion of students, quite a large proportion of students who do work on this course through VLab and through other systems because they just aren't too comfortable setting up things locally. So we try and essentially focus on making things available for the lowest common denominator. That's why we try and do things through VLab, because it's just, you know, it's like more accessible that way. And I wouldn't do this all the time on VLab. Like, you know, I didn't log into VLab to write the allocation script for groups and stuff. But anyway, so I've got this thing, print. What do we have on the slides? We had something on the slides, which was print hello world. So if I've got this Python program, print hello world like this, this is just Python code. And if I want to run this Python code, I can simply save it. Right? And I can run it. Now, to run it in the terminal, the way you do that on CSE is you go Python 3 and then my file. So you do need the 3 for now. We'll talk about that later. But what this does is this says, hi, Python interpreter. Think of this like GCC, except it won't just compile it. It will also run it for you. Okay, sorry, my screen just flashed. It will also run it for you, which is super convenient. So now when I hit enter on this, I actually get this output here. So running that, I get hello world, which is super useful. Just closing some browsers. I think my computer's like just been open for too long. Okay. Too much stuff. Got like literally about 700 tabs open. And music editing software and God knows what else. Thanks for bearing with me here for a sec. Okay, tons of stuff is closed. Yeah, so we run Python 3 like this, right? Python 3, it runs the code, we get an output. That's totally what you'd expect. If you write like another thing like Python goodbye, then and you run it again, you'll get a similar result. It'll just say like more text. So that's writing Python. That's the interaction you have with Python. It's super, super simple. That's the best part about it. There's no GCC -wall -where or anything like that. It's just like Python 3. Now, for the lectures, we're going to go through a bunch of Python examples, and we're going to start off with a basic Python example. Now, I won't look at the slides a lot for this stuff because we're actually going to clone the repo, the lecture code repo, and we'll work through that. And which is a great opportunity actually to kind of show you the lecture code repo. So at the top of the lectures page, I can go to this thing which is like, let's log into VLab and have a look at the code used in lectures. This is a repo that I maintain and provide to you. And what you can do with it is you can actually go to clone, and you can clone it to like your own local machine. So I can paste this in here, I can go git clone, and when I clone that, it's going to make a new folder called content. And when I go into content, I see lecture code, and then I see these different folders here. Now, what I've started doing this term is breaking up the lecture code on like a per lecture segment basis as opposed to a week. So that's why you see 1.3 and 1.4 here, and then week 2 is going to get broken up into smaller chunks as well as I just finalize things. So I'm going to go into 1.3, and then we'll see a whole bunch of files. So the first file I want to open is types. It's a really basic stuff. Now, if we have a look at this Python code, what you'll see here is that the first 3 lines, we're creating variables. And these variables here don't have types. That's the biggest thing you'll notice. We're not creating a char star and an int and a double. We're just creating stuff. Now, when I say they don't have types, what we're really saying is that we don't specify the types. It's what you would not call a strongly typed language. Every language needs types somewhere. It's got to work on a computer, and a computer needs to have an understanding of data size, and data size is inferred from its types. But the point is that you don't have to specify that. Python figures that out for you. Python sees this and it goes, that looks like an int. Python sees this and it goes, that looks like a string. Python sees this and goes, that looks like a double. And it does that for you automatically, which means that it just kind of works. There's Python also has some other operations in it that you can use. For instance, we have the power thing. So in C, if you wanted to do like 3 to the power of 3, you would normally have to do something like, include math.h, and then you'd say power 3 or something like this. In Python, you can just use the double multiply symbol to, raise thing to a power. Obviously, you have all of the standard things, like you have all of like the divide plus, like it's a standard programming language, but there's extra stuff as well. Blake says, will it make sure things don't overflow? Yeah, so if you're a good C programmer, you're thinking about overflows, you're thinking about stuff like that. You're thinking about where is that string actually stored in memory? What happens if it gets bigger, etc. And yeah, Python handles all of that for you. A lot of high-level languages do. In fact, one thing about a high-level language like Python is that it has a notion of what we call garbage collection, which is an idea whereby so to understand Python again, I mentioned that everything's typed deep down. Everything's also malloc deep down. Like Python uses malloc and things like that. It just manages it for you. It's what we call a language that deals with like, not user-controlled, user-managed memory. So things like malloc and pointers and all these things and types, when I said they don't exist, again, that's an oversimplification. They do exist. Every language basically has them. It's just that you're not interacting with them because Python's dealing with it for you. It's what we call a high-level language. It's just simpler to write. Naturally, this makes the language a bit slower, right? Because the computer's doing lots of things for you. It's like treating you like a baby. But that's a good trade-off a lot of the time. So we have a couple of operations like this. And you'll see if I just do something like printing num, for instance, print num2 and print num1, you'll see what the results of these 2 things are. So Python 3 types. Oh no. This didn't happen before. So I think it's actually funny that this happened right on one of our first language things. So if I'm not mistaken, let me just try something here. I'm gonna rename types to type.py. And then I'm going to run type.py. So one funny thing about Python, and normally students don't run into this until week 4, but the example that I've changed this term meant that I renamed the file, is that if you rename your file, if your file name is something that's also a Python library like math or other things, you can run into problems sometimes. So in this case, it didn't like the file name types. That's a really obscure error that some people run into with the project once or twice, but largely you don't need to worry about that. So I've got my Python file here, and you can see that it printed out 27 and it printed out 9. Now, what does this double / actually do? I don't know. You'll see things like this all the time, and we won't have told you in the lecture, so I'm going to Google it. Python double / or double divide. I'll Google it. Python is extremely easy to read about online. I see this article that says lesser known arithmetic operations. That sounds good. We have a quick look at this, and I'm going to search for the double /. Oh, okay, here we go. The double / in Python is known as the integer division operator. Essentially, it will divide the left by the right and keep the whole number component. Okay, that's quite interesting. So what that means is, like, if I have 27 here, what happens if I make this 28? And then I run that. I get 9. Whereas what happens if I make it just a single forward slash, we get 9.333. So you can see that it's basically a way of saying I would like to divide this number by another number, but just keep it as a whole number. You know, it's kind of like divide and round. These are just features of the language that you kind of slowly get your head around over time. The other kind of big thing, and where I really want to start with Python, is printing, because printing is one of the most common things you do. And if you can print, you can debug and you can learn. But if you can't print, you can't debug and you can't learn. So let's have a look at some different ways to print things. Let's say I want to print out my name, my age, and my height here somehow. One of the ways I can do it is what we call concatenation, which is the idea where you can join elements together by using a plus between them. In this sense, a plus is not arithmetic summation. It's just like joining. So in C, you do something like printf %s, %d, %d, and then you would say name, age, height, like this. Though again, another way to do it in Python is to actually join, whatever the % is with that comma space, with another variable, with the comma space, with another variable. We call this string concatenation. One thing you'll notice about this approach, right, is that with this approach, you find that if you're trying to concatenate something that's not a string with something that is a string, Python doesn't like it. So if I try and put age here, if I try and join name plus a string plus age, name's already a string. Python here says, sorry, we just noticed that you tried to join a string and a not string, which is this part here. So when you're printing things, Python will ask you to sometimes convert them to strings. In C, you might be familiar with casting. In Python, you kind of have a simple thing where you can actually take what Python generally considers to be a number and convert it to what it generally considers to be a string, like that. And then this will yield what you want, which is a simple printout. Another way that you can do things in Python is you can simply print things with commas. This is a common way that I debug. I just say, I'm interested in these 3 variables. I'll just print them all out and put commas between them. The print function in Python will literally just take variables and start printing them to the terminal. Where Python starts to get more interesting is you can see that the 4th argument I'm going to give it is not another thing to print, but it's actually this like weird argument where I say that a variable name equals a value. And we get more into this later in the course, but I'm just kind of flagging it now because it's an obvious difference with Python, is that Python can take in what you would call named arguments. Or in this case, what I'm saying is I want you to print name, age, and height, but when you print them all adjacent to each other, I want you to put a separator in, which is just a comma and then a space between all of them. And what that'll do is that will again yield the same result. Now, I don't normally print like these 2 methods, and you probably aren't going to either. The point of this is that there's a little bit more diversity than you're used to, and it's something you'll have to get kind of adjusted to, right? Like this is just what happens in Python. There's more ways to do things, and it feels a little bit more confusing sometimes. The most common way we print things is from a language feature that's introduced. And as POG. What does POG even mean? Yeah, draft POG 18, POG 2048.11. So the most common way you're probably going to print is using something called f-strings. Now, f-strings are a language feature that I think was introduced in 3.7. Sorry about the sirens. I don't know if you can hear them. And what f-strings are is they're a little bit like, you think of them like C-style printing, where what you do is you actually just define your string literally, but instead of the %ds and the %s's, you actually just put the variable name straight in there. Now, the problem with this approach is that if I was to just do this, watch what the output is. It just does that. It just prints it literally. That's good. That's what we expect Python to do. But since I believe Python 3.7, what happens is if you put f before any string, what you're telling Python is, hey, this string's special. There might be things in this that are variables. Can you have a closer look at it? So Python then has a closer look at it, and what it looks for is it looks for any instances where it sees some braces. And if it sees some braces, it looks inside that and it tries to check if there's any valid variables of this name, or it will just process it like it's code outside of a string. So it doesn't just have to be variable names. You could also do something like this, 1 plus 2. And with that F in front, it turns into an F string, which is like, it's like a processed string. And now we get something like that. So that's probably the easiest way to actually print things in Python, is using F strings like this. In Python, you can print types. So for instance, if I have a name, an age, and a height, I can print the types of these things. Like as I said, they do have types. It's just that they Python figures them out for you. Now, you can see when I print these types, we get this printing types: class, string, int, and float. What is a class? This is that, this is that object-oriented part that I mentioned, which we kind of largely can avoid in this course, but it tells you the actual type there pretty clearly, right? String, int, float. So you can see Python has interpreted those things. I don't know if Python has doubles. I can't remember. Angela says if you use the second or third method, you don't need to convert age and height into strings. Yes, that's correct. And in general, I use what's on line 11 or the third method. The only time I'd probably use something else is line 10, where I just want to print things quickly. Like I just want to print debugging output, and I wouldn't even use the separator. I would just print them normally, because the default separator for this kind of print is actually a space anyway. So if I was to say get rid of the separator, it will just print them out. It's just it'll use a space between them instead of a comma, and that's often adequate for like simple debugging. And you can see at the bottom here, here's another demonstration of F strings, whereby I want to print 3 to the power of 3 equals, and then the result. So I put the actual result here inside the braces, and then I just put an F string in front of it, which again tells Python to say, okay, go look at what's inside the braces and calculate what's inside of that. Someone says, can we use the %s method in this course? If you find a reason to that F strings don't help you with, I would encourage you to post on the forum if you think you've come across that, because just generally speaking, F strings are kind of just cleaner a lot of the time. But let's always have an ongoing discussion about that. Okay, cool. So they're the basics of types. Now, the next little thing I want to look at is some simple stuff on strings. There's not a lot to talk about with strings. Jeremy says, isn't the double divide meant to be an integer result? Yeah, but I changed it up here. Oops. Yeah. So with strings, one of the coolest things about Python and most other languages is that you can basically use strings in Python without having to think about them as character arrays or malloc things and overflows and null terminators and all that kind of stuff. You can actually just treat them like simple humans. Now you can see in this particular case here, I've created a variable called sentence, which is going to be the string my. One cool thing about Python is that its strings are dynamic, in the sense that you don't have to worry about how much space is here. You can just do stuff with it. So on the second line here, I'm actually going to say sentence is equal to sentence plus name is. So what that's saying is that, hey, go get the current sentence, join it to name is, and then create a new sentence, right? Kind of like updating it. And you can see here, this is another demonstration of string concatenation, where I'm joining two strings together just with a plus. Really simple. And then the third line here is that I can actually do plus equals, and we all know what plus equals is from C. It's like sentence plus equals Pikachu is the exact same as saying sentence equals sentence plus Pikachu. So you actually even have these nearly arithmetic operations here where you can just extend a string if you want to. And what this will lead to, naturally, is this will lead to you being able to print out my name is Pikachu. Nice and simple. Strings are great in Python. Like, the Python data structures are just one of the greatest things ever. There's a lot of things I don't like about Python as someone who spends most of my life doing a typed version of JavaScript. But its ability to work with data structures is just like great a lot of the time, particularly strings and stuff. So this point on line 7 here is not something that's actually that common either, but it's more just to demonstrate the kind of sometimes absurd power of Python, and particularly strings. You can actually multiply a Python string by a number, And what it will do is it will repeat it for you. So if I do this one, it's actually going to just print hi 10 times. It's like, all right, well, here's hi. And because I'm multiplying it by 10, I'm basically telling Python, can you just turn this string into a string that's like hi 10 times? Why is that useful? I don't know off the top of my head. I don't really use that particularly often. Well, I have a couple of random examples, but you could just avoid it. But it's interesting, right? It's interesting how powerful it is. It's interesting how capable it is of just doing these kinds of complex operations just like that without thinking about memory, without thinking about a whole bunch of other stuff. So that's kind of like the basics of strings. We're going to get into a more detailed example with strings, though, in a sec, when we get into lists and tuples. The kind of last comment here on strings, though, is that strings in Python are immutable. And what that means is, this is a very small detail, but what this means is that when you actually do something like this, you're not actually modifying the same string. The way to think about it is that Python is basically mallocing a new string every time. So when this first line was created, Python mallocked a string with, say, size 3. Well, more than that. Let's not overspecify it. It mallocked a new string, and then on line 2 here, it actually mallocked another string. So if you think, I know some of you have done 2521 or other courses, you know, it's kind of like dynamic memory, right? It like mallocks this, and then it mallocks another one, and then it mallocks another one. So Python strings are immutable. Once they're created, Python tends not to modify them that much. It kind of creates new things. And again, this can lead to performance issues as well. Like, there's a reason Python is slow. We might talk about performance stuff a bit later, but kind of moving on. One, strings type's really simple. One of the more interesting things about Python, which will be a big breather for people coming from C, is their notion of lists. Now, we have this idea of Python lists, but I don't want you to get too caught up in the idea of linked lists, because it's very easy to jump to that. But in actual fact, Python lists are essentially a hybrid of Python arrays and linked lists. So in Python, you don't have arrays and linked lists. You kind of just have these array lists, these array linked lists that are just these generic concepts of, you have a collection of ordered items. How is it stored? Who cares? That's not why you're using Python. You're using Python to do things easily and quickly. So if we have a look at this code here, which is our list tuples code, you'll see that I can create a list really easily, right? Hayden, Jake, Nick, Emily, like that. There's my list of 4 items. Now, with that list, if I just get rid of some other things. Also, actually, quick point, sorry to have kind of glossed over this, you would have noticed that I've been commenting things out with a hash. That is another difference with C. In Python, we have 2 ways of commenting, which is to put a hash in front of a line, like this. Or if we do 3 double apostrophes and another 3 double apostrophes, that's really the equivalent of the /* and the */. So this is what I mean. This is an example of identical concepts, different syntax. You know how this works because you've learned this before. You just learned it with different things on the keyboard. So that's me commenting some stuff out because I want to play around with this. So if I now run Python 3 list tuples, you'll see that I get here, ignore that Y, that's just from running the code. I get the printout of the list, like this. Hayden, Jake, Nick, Emily. So Python's very comfortable just printing out a list. You can make a list and print it out. You can also index items in a list, just like C, where you can get the 0th index, which in this case is my name. So like, bam, now I get 2 as Hayden. So you can actually extract particular indexes for it. I can also update an index for a list. So if I want to change Jake's name to Jaco, Jackio, I didn't think about that as I wrote it. If I want to change that, you'll see that when I print out names now, that Jake's name's been updated to Jaco, Jackio, whatever. And you can actually modify elements of that, just like a C-style array. So it kind of feels like a C-style array, right? And effectively, most things are arrays deep down. I'm pretty sure a Python list is just an array, even though they call it a list. I mean, list makes more sense, right? Like if you're trying to learn programming and you don't know programming and someone refers to something as an array, it's like, what in the world is that? If someone's like, this is the list, you're like, yeah, I get lists. I've used lists before. They're just like write things down. You can also add to a list. if you have a list like names, you can actually take the variable names and put a dot append at the end, which is like calling a function on names. We'll talk a bit more about this next week, which will add a new name to the list. And there you go. Now a new name's been added to the list. So again, super powerful, super easy to manipulate stuff. Really great. And so I was just reading a couple more comments. Yeah, so essentially, when you have like Python lists, they're going to be a lot easier to work with than, you know, how would you put it? Than C style lists. And I'm sure there's probably already like a little bit of a nice feeling you get from all of this, right? Like you're like, oh, this seems so much calmer. One way that Python is subtly different is that it also has this data type called tuples. Now, tuples in Python are basically lists, except they can't be modified. And that's the easiest way we like to teach them. So when you have something like a tuple here, right, what is the difference? Well, when you create it, instead of using the square brackets, you just use the parentheses. That's it. It's exactly the same, and you can pretty much interact with it exactly the same. The only difference is you can't modify it once it's created. So if I want to create a tuple like animals, and I want to print out the list or tuple, and I want to print out the first element, it'll do that for me. There's the tuple. There's the first element. Parentheses, not braces. Not square brackets. However, if I try and do something like this, I get an error. Oh, get rid of the prohibited. I get an error here, and it says, tuple object does not support item assignment. Basically, it's like, hey, I'm a tuple, not a list. Even though I'm structurally the same, even though you interact with me the same, don't touch me, right? Like, don't mess with me. I'm as I was born, and I will never change. That is it. Once it's defined, it doesn't like to be modified in any way. So for instance, same thing here. If we try and add to the tuple, we get the same thing. Tuple object has no attribute append. It's like, it doesn't even have the functionality to add things. It's like, it is just how it is. Now, the then question arises, why in the world would you have that? And the simple answer, like the simple way we've described it here, is that lists are for mutable ordered structures of the same type typically. You can have different types in it, but generally if you're using a list, it's good practice to try and keep the same typed element there. You don't define the type, I know, but you know, like just generally the type. You know, it can be ints and doubles, but you wouldn't want to make a list with strings and ints. Like just you're approaching the problem wrong if you're doing something like that. Tuples, though, on the other hand, are for immutable ordered structures, typically when you have a mix of types. So the most common reason you use tuples, as I tend to explain it to people, is essentially when you would sometimes use a struct, right? Like what's a struct? A struct is a collection of a few things that are sometimes different, that is not going to expand or whatever. It's just an easy way to just package it up. Done. We'll look at some more examples of this in later examples. Though for now, tuples are often really useful for things like I use tuples for when I was writing the preference allocator for the class, and I used a tuple for everyone, and like I said, your ZID was this, and your tut was this, and that was what I used a tuple for, because I was like, I just storing some stuff. You know, I just wanted to group things together like in a tiny little struct. So I kind of had a thing that was like, you know, students are technically I had a list of tuples, so I had something like this where I was like, you know, these are the students, like this. Technically that's a list of lists, right? But because the inner one's tuples, they're read-only. At this point in life, you don't even need to worry about tuples. You don't need to stress about it, but it's a great thing to do if you look at the things you're adding to a list and you think, well, that's not going to change. It's just a little bit cleaner. Okay, great, lists and tuples. I think just as a heads up, so because of the timing of this lecture, we're likely to run till like, I don't know, 10:10? something like that. 10:15, and then we'll take a break, and then we'll talk about testing. So just hold in there. If we're going too long, we'll take an early break, but we just want to get through it. So another very powerful thing about Python lists is this idea of slicing. Now, slicing a Python list is essentially a way of extracting a subset of information. Some of this you already know. So if I open slicing, and we have a list up the top here, a list of chars, A, B, C, D, E. You can see that we can print chars. We can print the 0th index of chars, the 4th index of chars. That all makes sense. At least it should to you. You know, that'll print the list, it'll print A, it'll print E. Great. Python gets weird in two particular scenarios. One is that in Python you can have negative indexes. Negative indexes in Python are essentially ways of starting from one direction going the other. So for instance, like in Python, you know the standard things like 0, 1, 2, 3, 4. That's how you get items in a list. But you can actually use negative indexes to go from the other end, like -1, -2. This can be really useful because if someone says to you, hey, can you get me the last element of a list? How would you normally do it? Well, you would normally do it like I would. You would say, okay, length of chars -1. And this is a great opportunity to point out that's how you get the length of a list in Python. You don't need any count. You don't need to like keep track of the size or whatever. Like Python will just figure it out for you when it's running. So if you use a len function and then you put a list inside of it, Python will just figure out how long that list is, which in this case would be 5, right? Because there's 5 items. So if I wanted to get the last element, typically I would do something like this. I would say, just like getting rid of these, I'd say, yep, length of chars -1. And when I run it, I get that A, B, C, D, E, and I get A, E, E, the last element. But with Python, I can also just say -1. And that will say, can you get the last element? And if I say -2, it will get the second last element, right? There's lots of detail to this. You'll use this sometimes, maybe. It's the point of this lecture is more just to kind of platform that there's a lot of things. There's actually things that we're going to talk about today that we're going to talk about in more detail last week. We're just talking about it now so that you feel like you have a little bit of a platform to be like, I kind of see the basics of this language. I don't get it all yet, but I get what this is about. The more interesting part of this example, though, is array slicing, which is something you really don't see in a ton of other languages be so easy. When you give an index in the square brackets a particular number, what you're telling it is that I'm going to give you a list and I want you to give me a value. Another thing you can do with Python is you can say, I'm going to give you a list and you're going to give me a smaller list, potentially. So if you have a look at something like this here, what this is actually saying is that given the Python list chars, I would like you to give me a sublist that's still a list that is all the elements from 0 to just before 1 in terms of index. Now, what elements is that going to be? It's just going to be one element A, right? But if I make this 2, it now says I want to get everything from element 0 to everything less than element 2, which is 0, 1, not 2. And now I get a subset list like this. And I could keep increasing this from 3 to 4, like that. And I can get subsets like this. I can also change where I start from, like that, B, C, D. So I can say start from the first index until the 4th index. And all of these examples here are just the same thing. If I say to Python, go from 0 to the 15th index, what does it do? It pretty comfortably says you're a moron and just gives you what it can, right? It's like, hi, I don't have that many elements, but here's what I do have, right? So again, a very friendly language. And then you have more complex examples, which I don't even bother to remember how this works off the top of my head. I mean, this one says, go from the second last element to the 4th last element, which should give us DCB? No, that does see exactly. Like, I don't even know this stuff. Like, there's so much obscurity to this language, and like people have shared in the chat, print chars : -1. I know what this does, right? It prints it in reverse. It's a bit of a weird thing. This is even more slicing you can do. You know, the double colon's another whole thing, right? And then it just gets deeper in every direction. So we're just trying to talk about the high level stuff. But this actually makes sense here why this prints nothing out, because the second last element is the, you know, the third index, and the fourth last element is the first index. And when you say this, Python's like, how do I go from... It's kind of like when you say to someone, can you give me all the books at the library that were booked out between 5 p.m. today and returned by 9 a.m. this morning? It doesn't exist, right? So that's why we get nothing in this particular case, because there's just nothing to return. Slicing's really powerful. Again, there's stuff I don't know or I forget. You can see that right there. That's totally fine. We're just pointing this out because you'll see this around the internet when you Google things. And it's like, that's what it is. Now, last few things, we might actually have to take an early break. Python functions. Thankfully, functions are really easy to talk about because they're just... Did I not add this one? Oh. Maybe I forgot to push. This is an example where I wrote some code locally and I don't think I pushed it to the Git repo. So therefore it's not there. But like this one is... This one is how we're going to make some Python functions. Now what you'll see about what? Great. What you'll see about Python functions is that they're really similar to C structurally. Function, parameters, does some stuff, return. I don't even want to talk about this very long. I just want to point out one of the main things that's different is that you don't have any types in Python, so therefore you don't have a return type at the start, you just have def. Def is for every function. Every function starts with def. Other than that, nothing's typed, and everything else is pretty similar. This is a function that deals with... I feel like I just jumped over control structures. Okay, right. I just realized that I skipped a slide here. So, like, there's like for loops and if statements, which I was just about to talk about, and you're probably like, what in the world is that? But it doesn't really matter, because, like, you get functions. The point of this is actually just to demonstrate to you how boring functions are in Python. They're exactly like what you would expect. So let's talk about more interesting things where stuff is slightly different. Blake says, do you have to define the functions above where they're used? I think so. Yeah, you do. That's what it's another procedural programming language in a lot of ways, right? It's very similar to C. That's one other good thing about it. But before we jump ahead, let's have a look at control structures, which is a more interesting case, where we look at ifs, whiles, fors, and whatnot. And in the case of control structures, I've kind of broken this up into 3 different parts. I've broken it up into if-else statements, while loops, and for loops. Now, if statements are pretty simple. I've got some notes up the top here about some of the differences. Have a look at just this if statement. Focus your eyes on just this bit up here. Some things you notice immediately. Firstly, rather than using curly braces, Python uses indentation and a lack of curly braces to denote order. So in C, you could kind of write something like this and just leave it like this. You didn't have to have nice laid out code because the braces were defining the structure and flow for you. In Python though, that's not the case. In Python, this indent actually means something to Python. It actually says, hey, I'm inside that if block. And the colon says, like, we're about to begin an if block here. The other thing you'll notice is that in Python, it's generally considered good practice to not use parameters unnecessarily. So for simple conditions like this, you don't need any parentheses, sorry. You can just like write it like this. C will fail to compile if you don't put parentheses there. One random side effect of Python though is without the braces, like normally with another language, you could just have braces that then like had nothing inside of them, and the compiler or interpreter would be like, yeah, okay, you just don't want to do anything, sure. But with Python, that's a bit more problematic because Python gets a bit confused. So if I try and run this code, for instance, Python 3 control structures, what happens is that it just kind of fails because it's like, I'm so confused, Hayden. You said there was an else if statement here, but then you jump to an else, and I don't get it. I was expecting something to be indented. I was expecting something to be inside of it, right? I've used tabs incorrectly here. I'm sorry about that. I added some more examples really late last night because I was just like, I want to talk about some more things. So we do need like something to put there, but what if you don't want to put anything there? Well, you could put a print whatever, but that actually still prints a new line. That's probably something else you've noticed about Python. I'm going to add that to my list of, differences is that here it will actually print a new line. Oh, it won't actually go in there. So what we can do is we can use a keyword called pass. And what pass means is literally do nothing, but I'm putting it here so that the structure makes sense. So you'll see pass around a few times. Besides that, this is just standard if, else, if, else. The only difference is you'll notice that instead of saying else if in Python, we say elif. Just a decision with who wrote the language. Don't think about it too hard. The other stuff we see here is a while loop, which is very similar to C. You have a variable, a while loop. It follows the same rules as the above. One thing, though, that Python doesn't have is an I++ property, which is always this talk. Everyone always talks about this. Like, they're like, why doesn't it have I++? I hate I plus equals 1. I don't remember why that is the case, though. Off the top of my head, my memory of it is that someone writing the language made a very smart decision and said, why do we need I++? Why do we need to like have a totally separate language semantic to just be able to do that? They're like, I plus equals 1 makes sense. You read it, it tells you exactly what it's doing. Why do we need to like create another way to do things, right? And that kind of leads to one of the general philosophies of the Python language, is just to keep things very structured and simple, right? I've probably said this in another course somewhere. Cool. One of the last things about control structures, though, is for loops. So in Python, we have for loops, but they behave a little bit differently. You don't have the same kind of like, for I equals 0, I less than whatever, I plus plus or whatever. This is actually the equivalent of how you would do in C, for int I equals 0, I is less than 5, I plus plus. Okay, and well, there's lots of other ways to do for loops that we're actually going to talk about next week or later. But for now, it's like you just need to know how to do a basic one, which is like, okay, what this will do is this will do a for loop. It will loop over 5 numbers from 0, 1, 2, 3, 4. That's what range returns. Range actually returns, that'll make more sense later. But this is kind of like an easy way to like iterate over elements if you want to. So if you want to kind of, and we can print stuff out here. Like I can just say, hello there, I. And then if we look at this, we'll just run it. Oops, I forgot to put the F in front. Classic problem. There you go. Now it's printing out 0, 1, 2, 3, 4 like that. Super, super simple. So where there's lots of different ways you can use for loops, and it's very powerful in Python, though we don't want to start there right now because it can get pretty confusing pretty quickly. But that's kind of the basics of the control structures. It's mainly syntactic, the differences, but the flow and stuff is all kind of the same. For loops are a bit weird, but that's about it. The last thing we want to talk about before we move on to the next lecture is definitely just dictionaries. I do want to spend some time on Python today rather than some of the next topics, because we'll get through the next topic pretty quick, though I'm cautious of time. So let's have a 5-minute break right now. I'll pause the recording. Okay, we're back. Reading the chat again, I think it's a great time to reiterate too. You're going to teach yourself Python just by, you're going to teach yourself pretty much every other language you learn, probably, realistically. Like, you'll never do a course that goes through it in as much detail as C again, I guess. But our job is to make you feel comfortable with that idea. That's why we're here today. So that as you're teaching yourself many of these things, because you could spend a whole term on it, you're like, this is less scary than it seemed. So the last kind of core concept, and we actually have a whole lecture talking about this and lists next week in a lot more detail, is Python dictionaries. Now, Python dictionaries, let me just get my fat head out of the way, is think of Python dictionaries like structs. So you should be familiar with structs in C. They're definitely not the same as it, but conceptually it's a good enough match. You use a dictionary in Python. Don't get caught up in the name. It has nothing to do with the book. You use them when you need a collection of items that are identified by a string description rather than a numerical index, right? So think about a linked list. With a linked list, you used to say like data and next or value and next. You weren't saying index 0 and index 1. You were describing the properties of those elements via a word, essentially a string. And Python dictionaries are kind of the same thing, where if I want to say create a structure, think of it like a list, but I don't want it to be just Emily, 99, 1. That's just a weird, awkward list. It's got different types. They're not ordered. It's not like Emily's the first index and Score's the second. It's like, no, they're just three things I want to group together. We can use dictionaries for that, where each element is identified by a string. And what that means is that if I want to do something, I mean, let's pull this up in code and have a look at it. If I open up Dictionaries and I run this, what I can do here is like I can print out my dictionary, which will just print out all the information. It says, yep, name Emily, score 99, rank 1. Yep, done. But I can also print out the value at student name. Notice how instead of using, it's like a list, but instead of using indexes here, we're just using strings. So we're using strings to actually identify particular things. And just like a list, you can update it too. You can say the student's height's 159, and you'll notice here that I've just added it to my dictionary. So super powerful. You're going to kind of want to use this for your project a little bit. But again, we're going to talk about it more next Wednesday. It's just, again, I want to get it in people's heads, because I think if you don't, I think if you haven't played with it before, it's not going to be like fun to pick up on by yourself. But there's lots of different ways. I mean, I see people in the chat talking about different ways to interpret it. But more than anything, particularly those who haven't done some more advanced computing courses, think of it like a list structure. Except instead of indexes, you're using strings to access things. There's more nuance than that, but that's an easy way to start. And it's a very powerful thing that you can't do in C. This is probably like definitely the top. String manipulation, dictionaries would definitely be, I think, at the top two things that you miss out on in C compared to Python. But again, we're going to talk more about this next week. It's just, this is a simple example for you to wrap your head around as well. The last example I have today is a thing on combining all of these together. So I've got a file here called combining, where what we're doing is we're actually going to combine a few different concepts together. In particular, I'm going to combine a few dictionaries and into like a list structure. The reason I'm combining this here is because you don't just work with lists and work with dictionaries. A really common thing in the course is to actually work with like lists of dictionaries or dictionaries of dictionaries or lists of lists or lists of dictionaries, like all these kinds of things, is to actually combine these data structures together. So what I've actually got here is I've got myself 3 dictionaries with just name and score. Now, naturally, they could be indented like this. I've just put them all on one line, so it's easy to read. And if I run this, what you'll see is the first line it prints out is actually the entire data structure. And the reason this data structure looks like this is because I haven't just defined 3 dictionaries here. I've actually said, all right, I'm now going to create a student's list that is made up of those 3 dictionaries. So instead of being 3 numbers or 3 strings, it's actually just 3 dictionaries. And when I print it out, that's exactly what it is. It's a list, square brackets, of thing 1, thing 2, and thing 3. They're all just like together there in a list. That's what happens when I print the students. The real question now is though, how would I solve a problem with this complex data structure, such as print all the students who got an HD, right? So Emily and Nick did very well and I did very poorly, and I want to print that out. Well, an easy way to do it is to use like a kind of C-ish style for loop and C-ish style logic. C-ish, that's what I said. So first thing is I'm going to be like, well, the number of students here, I definitely forgot to push an update because this should be an underscore. In Python, we try and use snake case for things, but I'll push that update and you can see the lecture code later. So I got the number of students is length students. So that's going to be 3 in this case. Then what I say is for I in range num students. What this means is this will loop with index 0, index 1, and index 2. It'll loop while I is less than 3. Then what I say is a particular student I'm interested in is that like student's I. That's just a C style arrays. That's really simple. I've got my index and I just like, I'll show you, like I just want to get index I is just student like that. And you'll see when I run this, it actually just prints out, you know, there's the Hayden student, there's the Nick student, there's the Emily student. Then I use an if statement and I say if the student's score is greater or equal to 85. And I can do this because each time I loop, I have a dictionary structure here like this. And that dictionary structure consists of a name and a score. So I can access those elements just with a string here because it's a dictionary. So I can say, is the student's score greater than 85? And if it is, I would like to print out the student's name, which is another element of that dictionary, got an HD. Super fun, super simple, all of that. I'm not going to talk about approach 2 for the sake of time. We're going to talk about that next week. It's not going to stop you doing anything. It makes your code slightly cleaner. We'll talk about it next Wednesday. Aiden says, is it still considered okay style if you write the for loop on line 10 as forced? Absolutely. You can... Well, you wouldn't do that. That wouldn't work specifically. But again, I'm just giving you enough today to be able to write for loops. And then next week we'll talk about, there's a few different ways to do it, some tips and tricks, other data structures. Again, the point of today is that so you don't feel paralyzed in your ability to do basic things. Next week we talk a little bit more about how to play with data structures. Okay, so finishing this up, the elephant in the room is that with this course, we use Python 3 in this course. Python 2 is an old version of Python. It's still installed on most Linux machines because many things on Linux are still built with Python 2 because they're just old, and why would you break something that works? So Python, if you run Python on some machines, like yours, not the CSE machine, you might be running Python 2. On the CSE machines, like we use Python 3, on your own machine, we use Python 3. In this course, we use Python version 3.7. If you type in Python 3 on the CSE machine, it will run Python 3.7 for you. If you're on your local machine, like a Linux or Mac or Windows subsystem, you might want to run Python 3.7 manually, and I'll show you why. Like, I'm just going to open up my own Windows subsystem for Linux here. If I do Python 3 -- version, you'll see that my version locally is actually 3.8. And this could lead to some slight discrepancies throughout the course. But if I do Python 3.7 version, I don't even have that installed. So I didn't even have the right version of Python installed. So just that's something to be careful of. You can always download Python version 3.7 just off their website. You could install it a plethora of ways, but basically, we're using Python 3.7 in the course. Leave some feedback, please, for this lecture, and we'll move on to the testing lecture in our last 35 minutes. I'm not going to put this up here long. If you'd like to leave feedback, which you do because you're a kind person, then just pause the damn video. You can pause it live, you can pause it in the recording. I don't need to sit here for 30 minutes, 30 seconds and wait till you've looked at it. Yeah, as I've said before, I said before, camel case is the wrong thing. We do have a Python style guide. Look, you don't need to worry about style until we tell you to worry about it, and we'll explain all of that more. So in the meantime, just do whatever you feel comfortable with. There is a Python style guide there, which we don't actually expect you to read, but if you kind of want some guidance early on, that's the best place to look. The Python style guide is sitting here. It's just a link to Google style guide. We didn't write it. Cool. So that's it for the introduction to Python.